Here. Okay. So the tutorial today is about organic reactions that we have learned throughout the last lecture class on Monday, and there are worked examples is given here, and I am guessing that you have already tried all those things, the reactions. So directly I'll go to that self-testing question. I'm not going to actually do all self-testing question because it is quite those are quite what is the pen? All right. So the self-testing questions, some are very simple actually, then I don't need to talk too much about the self-testing questions. So first of all, the first one, it says that consider the following statement about the alkanes. So when we are studying the alkane or alkene, be careful of these A and E. This just because of an A, it is an alkane, and if it is an E, then it will be an alkene, and the difference between them is alkane are saturated. There is no carbon-carbon double bond between them. Alkenes are unsaturated. So alkanes, when they are unsaturated, this is hydrocarbon one, and alkanes react with hydrogen chlorine to produce chloroalkanes. No, alkanes do not react because they are very stable, right? And alkanes react with sodium hydroxide to alkane. No, they also do not react with any other things because it is very stable, and that is why they do not react. So the question number one, the answer is one only. Yeah. The following path, the reaction pathway, it says that from ethene, since it is an ethene, we know that there is a double bond between them. The mother molecule or the base molecule is from ethane, and it is modified to ethene. It could be ethane, or it is now ethene. It could be ethane. Okay, so this is, since it is ethene, we know there are two carbon chain, right? Two carbon, and then between carbon there is a double bond, so it is an ethene. From ethene it becomes a chloroethane. Chloroethane means the chlorine atom is added to that carbon. So carbon and carbon become, the chlorine is added. Whatever was there, it is still there. Only the additional thing is chlorine are now added to the carbon, and now it become ethane. It is not an ethene anymore. So it become ethane. From E, it becomes E. That means in ethene, it was double bond. In ethane, here chloroethane, there is no double bond between carbon and carbon. It's the chlorine, only the additional thing, chlorine is added there. From chloroethane, now it becomes ethanol. So chloroethane, sorry, another thing. It is chloroethane, so that means one chlorine is added, not two chlorine. If two chlorine, it would dichloro, it would be dichloro. So it is just one chlorine added, so it is chloroethane. Right, so only one chlorine was added, and now this chloroethane becomes ethanol. Ethanol, that means OH, this chlorine is gone from here, and OH is replaced to this, chlorine is replaced by OH. So this OH is coming from a base, sodium hydroxide it can be, all right, it's coming from there. And from this chloroethane, ethanol, the ethanoic acid, so it is CH3 or acetic acid that we know, that CH3, CH2, COOH. This OH, this H2 is gone from here, another O is replaced by this H2. So to take this hydrogen out and to infuse this one more oxygen, I need to have an oxidizing agent, potassium permanganate can do that, or potassium dichromate can do that. This is an oxidation is happening here. So the reaction is saying, the pathway, consider the following reaction pathway. What happened? So first of all, addition occurred because from ethane, I had to add hydrogen chloride to make it chloroethane. So that was an addition. And then chlorine was substituted, right? Chlorine was substituted from here by hydroxyl. So it's a substitution reaction. And then there is oxidation. So addition, substitution, and oxidation. That is how it goes. Question number 3 says, which of the following statement about propene is not correct? Propene, since it's a propane, double bond in between them, so yeah, it is an unsaturated. Yeah, it's true. It decolorized bromine water. That is true too. It is a structural isomer of propane. Is that a structural isomer of propane? Propane, if it is propane, then it should have 2 more hydrogen than propene, right? Propene has a double bond. So it lost 2 hydrogen and form a double bond. But propane, it opens up the double bond and binds 2 hydrogen. So propane has 2 hydrogen more than propene. So it cannot be a structural isomer of propene. So this is the correct. This is not true. That's why it's correct answer. 2 chemical reaction occurs as follows. What is the name about this? Methane, ethane, propane, butane, pentane. So it is a pentene. All right, it is a pentene, pent 1 in. We start counting from this side. 1, 2, 3, 4, 5. Because we start counting from that side because by this way the double bond is coming earlier in the count. So 2 pent 1 in, right? This is a pentene. And what is X? That makes is 2-chloropentane. Pentane means there is no double bond anymore, and then chlorine is attached. 2-chloro means there are 2 chlorine atoms are attached there, so there is 2-chloropentane. All right, so 2-chloro, so it should be a chlorine molecule, not a HCl. HCl, then it will be only 1 chloro. If it was HCl, it will be only 1 chloro. Since there are 2 chlorine, it should be a chlorine atom, chlorine gas, Cl2. And then the compound, that is the product from this reaction, it reacted with sodium hydroxide solution. So sodium hydroxide solution, it will produce, what will produce? It will produce alcohol, sodium hydroxide, OH, right? OH will produce alcohol of the from this molecule. But the question is, where will this hydroxide will go? Where that hydroxide will go? Hydroxide will go. So here, once again, sorry. Okay, let's start from here again. So this is pentene, pent 1 in, pent 1 in, and now it is 2-chloro. That doesn't mean that 2-dichloro. I previously just now I made a mistake. This 2 I took it as di. It is not a di. All right. It is a 2-chloro means the chlorine is attached to the 2 position. Chlorine is attached at the 2 position. Okay. So since chlorine is attached to the 2 position, there is no other chlorine, and the bond is broken. There is no double bond anymore because it's a pentane. Another one should be hydrogen here. So it becomes CH3, CHCl, This chlorine is here, and then CH2, CH2, CH3. 2 and CH3. So this is the product becomes from the first reaction. So this this X should be, since there is one hydrogen and one chlorine goes in, only one chlorine in this molecule, it should be HCl. This X should be HCl. This X should be HCl. Then 2-chloropentane, that means this is a 2-chloropentane, 1, 2, 3, like this, so 2-chloropentane. And if we add with sodium hydroxide, this, it will be a substitution reaction. This chlorine will go out and this hydroxyl will be replacing the chlorine. So it will be the 2-hydroxypentane. 2-hydroxypentane is this one. This and this is the same thing actually, but Y is the same thing. X is not the same. I mean, a similar thing. So B is the correct answer. Is HCl is X, and Y is the 2-hydroxy or pentane to all. Okay, it's the 2-pentanol or pentane to all. The following diagram says that unknown P, Q, R, and of course this is known. So what we have to find out from here, that what is the P, what would be could be the Q, what could be R. Only the clue is given that if we react with if we react bromine with P, Q is formed, H, hydrogen gas, then R is forming. But if we react with water vapor in catalyst, then it is forming alcohol. And there is 5 carbon chain in the main chain. There are 5 carbons in the main chain. So if 5 carbon, then what could be the backbone? Methane, ethane, propane, C3, 4 butane, and C5 is pentane. So pentane, right? It cannot be, P cannot be a pentane. It should be something that takes up water vapor under catalyst, in presence of catalyst, to produce hydroxyl. So it should be something like a double bond there. Only if it is unsaturation, then this reaction will occur. So P, from there we understand that P should be an unsaturated, and there is 5 carbon. We are not adding anything to reduce or increase the carbon number. Only hydroxyl is being added, no carbon added, right? So the carbon number should be same as in the base or as in the original molecule. So number of carbon should be 5. Here, P, the number of carbon original is 5,2. So it should be C5. And if there is one unsaturation, then it should be C5H10. That is a pentene. So P is pentene, that we understood. And if in this pentene we add bromine, what will happen? The same thing. Only there will be 2 bromine atoms added to it, because bromine is a diatomic bromine we are adding. 2 bromines are there, so bromine will, each one will go on either side of the double bond, right? It's double bond. 1 bromine is there, 1 bromine is here, like this. Bromine is here and there. So this is the, and then if we add hydrogen under influence of the catalyst, it will be not unsaturated anymore, it will be saturated. That means from pentene, it will become pentane. And the saturation, the formula for pentane saturation is CnH twice n plus 2. That means 12. 5 times 10, 10 plus 2 is 12. So R is 12. So A is the correct answer for this. Consider the following, question number 6, consider the following reaction pathway. The reaction for methane, ethane, propane is propene, right? Is propene. Propene is reacting with something to produce hydroxyl. The same thing that you have to add hydroxide, sodium hydroxide, potassium hydroxide, lithium hydroxide, you can add. And then from here, the propanol, it becomes the propanol, right? Propene, from propene, it becomes propanol. And from propanol, it becomes acid, aldehyde. It is an aldehyde, CHO is an aldehyde. So from how it can become from COH to CHO, that means 2 hydrogen gone. 2 hydrogen are gone. 2 hydrogen gone, we have to add water, nascent oxygen there. That means the oxidation reaction, so that they will go out as water and CHO there. So reaction X is a hydration. Yeah, it can be hydration as well. If we don't use sodium hydroxide, we can use water vapor. Just now we have seen in under the catalyst as phosphoric acid H3PO4. That way also we can. Since there is no base as an option for X, there is no base, right? No sodium hydroxide, potassium. So it is not the answer. Sodium hydroxide cannot be an answer. So we moved on to another option, that is hydration. Hydration means we add water to that. And the reaction Y is the oxidation. So A is the correct answer for this. Question number 7 says, which one of the following organic reaction does not result in the product shown on the right hand side of the reaction? That means it says that which one will not produce the product. Only one reaction is not correct, that is not producing the product, which one should be shown on the right side. So let's say for A, it is a methane 1, 2, 3, 4. 4 carbon means butane, methane, ethane, propane, butane, and the chlorine is at the position 1. So 1 chlorobutane. If I add sodium hydroxide, yes, the chlorine will be replaced. Hydroxyl will go in here, and it is happening. This is correct reaction. For B, I see that it is also 4 carbons, so methane, ethane, propane, butane. So it is 2-butene, E-N-E at the end of the name, butene, not a butane anymore because there is a double bond here. And if I add HCl, yes, the reaction will go on, the reaction will be occur. And what will happen is 1 hydrogen will come here and the chlorine, that is because hydrogen and chlorine, so chlorine will go there, or vice versa. Either way is the same thing actually. If you even add the chlorine is here, hydrogen is there, exactly same thing, right? So it will occur there. But for this reaction, it says the chlorine is going here and then the double bond, 2 hydrogen is attached to the double bond. It is impossible. There is the hydrogen will not go here. No, it will not. And the chlorine will not come here. Why? Because carbohydrate, hydrocarbon, this carbon and hydrogen, this bond is quite stable. The hydrochloric acid is not going to break it. So this is the wrong answer. For this, it is the true. It should be the correct answer as well. This is the ester will be formed because the alcohol and this is carboxylic acid. So ester under the catalyst by acid. H plus means acid, right? So yesterday lab we saw it also that we added sulfuric acid and then ester formed. So this reaction is correct reaction, and this is the correct reaction as well. Question number 8 says that consider the following reaction. What is the systematic name of the organic product? The product that will be formed, what will be the systematic name? The original reactant is HCl, that is hydrochloric acid, we know. And here it is methane, ethane, propane, butane, and this 2-butene. We just have seen it before here. This is the thing, number B. So this is the reactant and product, and the where's the product will be formed is chlorine is here, right? And hydrogen is here, not chlorine. So this is the product that will be formed. What will be the name for this? What is that? What will be the name for this? Let's say chlorine is added here and hydrogen is there. And there is no double bond for this reaction. There's only one bond. There is no double bond. There's only one bond here. So what will be the name for this? 2-chlorobutane, right? It's 2-chlorobutane, easy. Consider the following reaction. It is an alcohol. What is the name for this alcohol? We start counting from this hydroxyl, the group, where is the substituted group? We should start counting from there. So this is 1, 2, 3, and 4. You can take this one 4 or this is 4. Both are same. Both will be the same. So it is 3-methyl. The methyl group is substituted here to this compound. 3-methyl. The main or root is methane, ethane, propane, butane. Butane-1-ol or butanol. 3-methyl butanol. If we add potassium permanganate under the influence or under the catalysis of acid, that means it is having a strong oxidizing agent and it is producing a carboxylic acid. One oxygen will go in here, the hydrogen will go out. So this will be a carboxylic acid then. So 3-methyl butanoic acid, OIC, will be added if it is a carboxylic acid. How will it look like? So it will be like CH and then CH2, oh no, sorry, COOH. COOH, yeah, and then this CH2. So this is how it will look like. And now if you count on, you see that all the carbon has 4 bonds. 3 hydrogen, 3 bond, and then this bond, this one again. 3 hydrogen, 3 bond plus this bond. So this carbon has 4 bonds. Same goes for this carbon. This carbon. Let me take a different color. Can I take a different color? Okay. Yeah. So this carbon, this carbon, it is having the hydrogen 1 bond, 2 bond, 3 bond, 4 bonds. So all of them having 4 bonds. And this is the compound. So this is the 3-methyl butanoic acid. Oh, there will be another CH2, yeah, in between. Where do I put it? Okay, there will be another CH2 here. All right. Okay, methane, ethane, propane, butane, yeah. So 3-methyl butanoic acid. Okay. Go back to red color again. Okay, so this is it. Question number 10, it says that what substance would be produced if you were to react 2-chloropentane with ammonia dissolved in ethanol? If I would react 2-chloropentane, that means 2-chloropentane is chlorine is the main or the root is pentane. Only the chlorine is at second position, 2-chloropentane with ammonia. If I add ammonia, what would happen is 2-chloropentane, let me write. So CH3, CH, ethane, propane, butane, pentane, CH. All right, says 3. So here it will be 2, here it is 2, and there is a chlorine attached to this carbon. So this is a 2-chloropentane. 1, 2, 3, 4, 5 carbon, right? So methane, ethane, propane, butane, pentane. Now the question is asking if I would add ammonia, which is dissolved in ethanol. Why it is dissolved in ethanol? Because ammonia is a gas. In ethanol, it can be in a liquid form. You can mix. If I would add it here, what will happen is this chlorine will be replaced, and this totally gone from here. Let's say, all right, and ammonia is coming here. Not ammonia, but NH2. NH2 is coming. And what happened to this chlorine? There is 3 hydrogen here, and there is 2 hydrogen. So there's 2 hydrogen here. So there is 1 hydrogen left. This 1 hydrogen which was left, they bind with this chlorine to produce a HCl gas, of course, right? And left the system. So this will be the product. And this is the product. This will be the product. So the ammonia amino group will come at the second position, not at the first position. This is wrong. This is wrong. All right. So this is the thing that will go. B is the correct answer. Question number 11, it says that to prepare methane, ethane, propane, butane. So it is a butanoic acid. To prepare butanoic acid, the reaction pathway would involve oxidation of propane 1-ol. No, the oxidation of butane 1-ol, because if propane 1-ol, then there is 1 carbon less, only 3 carbon chain. But we are not adding any carbon there, that the carbon chain can be elongated. We cannot elongate the carbon chain. The carbon chain, what was there, is there. Only the substitute group, hydroxyl, nitrogen, amino, carboxylic group, all those groups we can add, or chlorine we can add. But the main carbon is we are not adding anything, so that from propane it cannot become a butane, all right, unless we are adding some carbon to that. But here we are not adding any carbon, we are just adding some hydroxyl or some other things that the main carbon, number of carbon stays the same. So the oxidation of butane 1-ol will produce us butanoic acid. Hold on. Okay, so now question number 12. It says that the raspberry flavored food additives, butyl methanoate, can be prepared from. Now again, remember, this is an ester. The ester, the first name is coming from alcoholic group, the alcoholic part. The name is taken from the alcoholic part, and the second name is from carboxylic part. So butyl methanoate, that means butanol reacted with methanoic acid, right? Butanol is reacted from methanoic acid. So, and the reaction is a condensation reaction, and it is happening between butane 1-ol and what do you call it, methanoic acid. So methanoic acid, if we say, which one is methanoic acid? What is this? This is very, I mean, we know this acid already for some time. We have been working with this CH3COOH. This is ethanoic acid, right? This is carboxylic acid or ethanoic acid. So this is not a methanoic acid. This is the methanoic acid. Methane has only one carbon. In the chain, it has only one carbon. So for this COOH, it has only one carbon here. But for ethanoic acid, there are two carbon already. So this is a condensation reaction with methanoic acid. This is the correct answer. Question 13, it says that which of the statements about the following organic compound is correct? It is a structural isomer of pentanoic acid. The functional group of compound is ester. Yes, it is true. It's an ester, right? And it can be hydrolyzed into ethanoic acid and ethanol in acidic condition. That is interesting. Whether it will be hydrolyzed to ethanoic acid and ethanol in acidic condition. So this is coming from, if we break it down from here, we see that methane, ethane, propane is propanol. Is propanol and ethanoic acid. So ethanoic acid will be produced if we do hydrolysis, but it will not ethanol. It will produce propanol. Propanol. It will produce propanol. Why? Because this part is coming from the alcoholic part, and it came from propanol. So why suddenly propanol? I mean, if we break it, it will go to its original thing, that's propanol. Why would it go to the ethanol? Then what happens to another carbon? What would it do? It cannot stay alone. So it will become propanol, not ethanol. How do we know that which one is which part is coming from what? The simple trick is there's the carbon CO group, right? The C double bond O. It is attached to which carbon? This carbon is attached to this carbon. That means this part, if there were another carbon, doesn't matter how long the carbon, it whole part would come from the carboxylic group, where the CO group is attached and the carbon is attached to the chain that maintains. This whole part is coming from COOH, that means carboxylic acid group, carboxy group, and the rest is from alcoholic part. It's coming from the alcoholic group or alcoholic part. So this is how we should be able to differentiate or understand. So yeah, it is a structural isomer of pentanoic acid. Let's see that pentanoic acid is methane, ethane, propane, butane, pentane. C5H pentanoic acid is H10 O2. This is the pentanoic acid. So yeah, this one is 1, 2, 3, 4, 5 carbon, 3 to 5 to 7, 8, 9, 10. There is 10 hydrogen as well here, and 2 oxygen. So this both A and B are correct. For this, A and B are correct. Question number 14 is that the aspirin is a compound widely used as a painkiller and to relieve the symptoms of fever. It can be produced by means of a reaction in which salicylic acid is one of this reagent. The structures of aspirin and salicylic acid are shown below. So this is aspirin and this is salicylic acid. Salicylic acid, yesterday we worked in the lab. You have seen the salicylic acid, that it looks like what do you call it, a bit crystal, right? It looks like crystal, doesn't dissolve properly nicely in the water. And the aspirin is very much similar to that, only here there is a little bit of extra something is there here. So this is the difference. Aspirin, we can use it for our Panadol, but not Panadol. I mean, aspirin is aspirin, but yeah, you know that we can use it for our health purposes. Salicylic acid, we can use a little bit of for food preservative purposes. So which of the following statement about aspirin is not correct? Aspirin may be prepared by reaction between salicylic acid and methanol. This is correct. This is an ester, right? This is an ester bond, ester linkage. And we see that this salicylic acid is the alcoholic part. So if there is a CH3OH, okay, yeah. So if there is a CH3OH, there will be a reaction and produce ester, is it? If I add CH3OH, let's say that okay, CH3OH, will it produce a reaction? No, because both are a hydroxyl group. I need an COOH group, right? And in that case, I would need CH3COOH. Only then there would be this ester would be produced. So by reacting with this plus this, then it will be produced, but not with CH3OH. So this is not correct. And the rest are correct actually. Formula for ester with strawberry fragrance is given below. This is a strawberry. The alkanol and carboxylic acid used to synthesize this ester are. Can you tell me which part is from ester? Sorry, from alcohol. Which part is from alcohol?
The bottom part.
Yes, the bottom part. Just now, thank you. I'm not sure, Eric or Brian. But so this part is from alcohol because this CO group is attached to this carbon chain. And it is discontinued by this carbon. This carbon is attached to this oxygen, right? So it is not directly attached to this carbon anymore. This chain is broken here, but the chain is continuing here because all the carbon is attached to another carbon. This part, the CO group where it is attached, is must have come from COOH, that's carboxylic group. All right. So this is carboxylic group. This group is coming from alcoholic group. And if it is coming from alcohol, what alcohol could it be? This methane, ethane, right? This is ethanol. This ethanol is coming from ethanol, and this group part is coming from 1, 2, 3, 4 carbon. So that means methane, ethane, propane, butane is the butanoic acid. So ethanol and butanoic acid reaction. Okay, so this is the self-testing question. And before I move on to the past exam question, anybody has any question so far for today? No. Right. So the same thing, past exam question, it says that 4 of the reactions of propene are shown in the diagram below. All right, this is the propene in the diagram. 4 of the reactions are shown, and question is, name the catalyst that is usually used in reaction 1. So if I add some catalyst or hydrogen in presence of some catalyst, then the double bond will be broken and the saturated hydrocarbon will be produced, that is propane. From propane will be produced. Hydrogen, of course, hydrogen will be needed because this hydrogen atom, one each is going to this double bond, either side of the double bond. Here is one, here is one, and CH3, CH becomes CH2 here, right? And CH2 becomes CH3 here because the hydrogen is added. This hydrogen is broken and added to there. What catalyst should we be using? Okay, so the catalyst is either platinum, this is PT, or nickel. Of course, in high heat, 170 degrees centigrade, we will be using platinum or nickel. Either one will do. Question number 2, it says that the 2-bromine is added. We can see that 2-bromine is added into that molecule, and there is no double bond. So, of course, the bromine, diatomic bromine is added. The bromine gas is added there. If we add hydrogen bromide, here question reaction 2 is that if we add hydrogen bromide, what will happen, right? Hydrogen bromide, then we will see that here one is hydrogen, here hydrogen is going, and for this carbon the bromine will be attached to this carbon, right? So this is the compound will be produced, CH3 CH2 CH2Br. Sorry, CH2Br. So this is the compound will be produced if I add hydrogen bromide. So one hydrogen, one bromine is going. What about for reaction 4, that 2-hydroxyl group is going in on the either side of this double bond. So far we have seen that if I add sodium hydroxide or if I add water, then 1-hydroxyl is going in. But for this case, I see that 2-hydroxyl is going on in here. So what actually should have been done or should have been done on it? The thing is, oxidation reaction we have done for this case, and oxidation it has been done with osmium tetroxide. This we have not discussed. These two O are the same size. OS is osmium and oxygen. So there are 4 oxygen into it. This is a very strong oxidizing agent. So this one, for this reaction, it produces a double bond. 2-hydroxyl will go into it. So this is quite strong. We haven't heard it before. I mean, we haven't discussed it yet. So now you know that osmium tetroxide is very strong oxidizing agent. Name the type of reaction. Reaction 4 is the oxidizing agent. Oxidation reaction. It's an oxidation reaction. It's okay. And question number 2 says that consider the following sequence of reactions. All right. And the reaction from methane and propene. Reaction 1 is 2-bromopropane is being formed. So hydrogen bromide, of course. We need to add hydrogen bromide, only then the hydrogen is going here and then bromine is going there. And from there it is propane, 2-aminopropane. So ammonia should be added in alcohol, AlCOH. Alcohol, ammonia is dissolved in alcohol and then it is added there. So for the first reaction, it is an addition reaction. Second, and hydrogen bromide is added. Second reaction is a substitution reaction, and reagent is ammonia. Right, I have written already. So this is an addition. This is an addition reaction, ADD, and this is substitution reaction. Give the structure form of organic product when 2-bromopropane reacts with potassium hydroxide. Same thing, the bromine will remove from here, hydroxyl will go in, right? So this is propane to all will be produced. A student was given 4 colorless liquids that were labeled A, B, C, and D. They were known to be ethanol, ethanoic acid, pentane, and hexene, but the exact identity of each liquid was unknown. All right. The student tested the properties of each liquid and obtained the following results: A, B, C, D. So we do not know what is A, what is B. A can be ethanol, A can be ethanoic acid or pentane or anything out of these 4. Same goes for B. So solubility in water, A is insoluble. A is insoluble, so that means it does not get dissolved into water. Addition of red colored bromine solution, color disappears. Color disappears, that means it is double bond. It has a double bond in it. Addition of sodium carbonate, sodium carbonate or sodium bicarbonate should have some carbon dioxide. So it does not have any carbon. If it is had a carbon dioxide, then it would have bubble or effervescence. So it does not. So it does not have COOH group. It does not have a group, COOH group here, right? So it is a double bond. It is insoluble. That means the organic chemical, and it has a double bond. So it most probably it is a hexene. B is soluble in water. That means it is a polar compound, right? That's why it gets soluble water. And with bromine, no immediate reaction. It doesn't show any direct reaction, very like that. So it does not have a double bond here. It does not have a double bond here. And then gas evolved. So it should have carboxylic group in it, right? So it should have a carboxylic group in it. And it is most probably is ethanoic acid. Most probably okay. I want to change color. I cannot change. All the color becomes same. Okay, so most probably B is the ethanoic acid. For C, it is soluble in water. That means it's polar as well. Now we probably understand. And addition of red color bromine, no immediate reaction. It does not react directly. And sodium bicarbonate, no carbon dioxide as well. So of course it does not have a COOH group. So, but it is soluble in water. From this hint, we understand that either it should be ethanol, because ethanol has the OH group, which is polar, and it gets dissolved. Ethanol is alcohol, it gets dissolved in the water. So most probably it is a C. And the rest, if we do not have to see, it is a pentane. So it is a D. Right? Not that we don't have to see, but after looking at it, it suits the pentane most. Name of the liquid, and also sometimes it will say that, okay, structure of the liquid. Draw the structure of the liquid. Question 3 says a chemistry book describes the properties of compound X as being flammable liquid, unsaturated, able to participate in addition reaction. Suggest a precaution to be taken in order to handle flammable liquid like this compound in laboratory. What for the what is that? Flammable liquid or volatile, very flammable volatile liquid. What do? We should keep it away from the ignition source, or we should not be working near the heat or flame, right? We should perform the test away from there so that it does not get, we don't get burned. And unsaturation means carbon-carbon double bond or triple bond between them. Question number 2 says the suggest a reagent that can be used to test unsaturation. Unsaturation, either we saw, now we know that bromine water we can use, bromine water we can use, and then also can use iodine solution, right? Iodine solution, both we can use. Chlorine does not have any color, so chlorine we cannot use. It does not, we cannot understand any changes. For bromine, this color of reddish brown becomes disappeared. Yesterday we have seen it. For iodine, actually yesterday I think we saw iodine. That iodine solution is a bit pink color, is it? Yeah, something like pinkish color, and it become fainted. Become fainted, the color, or faded actually. So yeah, by this way we understand that this unsaturation is there. Question number 6, name the compound. You can, okay, I'm sure that you know, but let me just go through. So we start counting from this side because there is a unsaturation is here, and 2, 3, 4. There are 4 carbons in that main chain, and it should make methane, ethane, propane, butene, because there's unsaturation. So butane become butene unsaturation. But1-ene to be precise. But1-ene, right? Or 1-butene as well. But this is the substitution or prefix that is happening at third position, at 3 carbon third carbon, or 3 position of the carbon. That means 3 methyl. This is a methyl group. CH3 is a methyl group. So 3 methyl but1-ene. So 3-methyl butene, right? The name. If it reacts with, who is X? Oh, if it reacts with HCl, what will happen is hydrogen will be here and chlorine will go there. So 2-chloro-but, the same thing. 2-chloro-3-methyl but1-ene. Oh, sorry, butane, not butene anymore because there is double bond is gone. So not butene. Question number 4. Let me see how many more. Oh, there is a similar thing actually. Similar things going on. So question number 4 again, the same thing. And what is the reagent X that should produce this type of compound? From a chlorine, we have to replace this chlorine with hydroxide. So it should be sodium hydroxide, so that it will be replaced by sodium chloride. And then this, what is the name for this compound? 1, 2, 3. This is methane, ethane, propane, propanol, right? Propanol is a potassium permanganate is a strong oxidizing agent. Potassium, remember that potassium permanganate, MnO4 or K2MnO4, sorry, not K2, KMnO4, right? KMnO4, or sometimes it is written just MnO4, and there is a negative charge there. Okay, so KMnO4 and there's another one, another set, that is K2CrO7 potassium dichromate, or Cr3O7. So this is two. So these two will produce the oxidation that will cause the oxidation. So this is the oxidation. In short, we just put the O in third bracket. That means the oxidation reaction is going on here. So oxidation reaction, if there is this oxidation reaction, then these two hydrogen will be replaced by oxygen here. So what will produce is CH3, CH2, and COOH. So carboxylic acid, it is produced, right? All right, so this is compound B. Compound A is, we do not know what is compound A, right? But the clue is, if we add with water or phosphoric acid, it is going to produce ethanol. So it should be CH3, CH2, Cl. Also can, right? It will be in that way as well, that can produce the compound. And then with carboxylic acid and ethanol under the reflex, under sulfuric acid, it will produce an ester. And you know how to produce the ester: CH3, CH2, CO. So this part is coming from carboxylic group, and then this part is coming from alcoholic group, CH2 and CH3. So this part is coming from, so this is the compound X is produced. Identify the type of reaction. So from compound A to methanol, it produces, when it produces methanol, it's an addition reaction. When it produces hydroxyl or alcohol to compound B, it is an oxidation reaction, right? Okay. So question number 5 is the same thing actually. I'm not going to talk this question number 5. Question number 6. Oh, this is the dichromate ion. So far we have seen permanganate, right? We have seen permanganate. This MnO4. So far we have used MnO4 permanganate ion. Of course, there is one negative charge. Or if I add K in front, then I don't need to add this negative charge anymore. We will learn more later on. So this is a permanganate, or this is a chromate. Both are used for oxidizing agent. So methyl chloride, if I add sodium hydroxide, the C will be produced. The C is CH3, CH2, OH. Ethanol is being produced, CH3, this one. Right, ethanol is produced, and if ethanol is oxidized, it will produce ethanoic acid, that is CH3COOH. Ethanoic acid. And with ethanoic acid, if I add the alcohol, it will produce under reflux an ester, the same thing. So basically this is the answer for all for tutorial 11. It's quite easy, but it needs practice for you. If you just listen and then you start, you forget, or you just don't practice at home, it will be very difficult. You will forget everything. Right. So this is any question anybody has so far? No. Then I want to discuss about how to draw the graphs for reaction progress. This is a reaction number equilibrium, right? Okay, I hope that you can see. Now the question here, he says, some student asked me about this. I think if I get you correct, then I hope that this is the thing that you wanted to ask me. You wanted me to show, right? Okay, so hold on. All right, so iron and thiocyanide is producing iron thiocyanide, right? And then if I add 1 drop of ferric nitrate or iron 3 nitrate, what will happen if I add iron 3 nitrate? Iron 3 nitrate, it will produce iron 3 plus nitrate 1 negative. So since iron is increasing, the Fe3 plus is increasing, so this iron will increase. If this iron is increasing, the reaction will move forward, right? That means you are adding more iron. So what will happen? Of course, it is going to the right side to balance the not sudden, but the addition of iron to that. So more iron thiocyanide will be produced as well. But since there is a limited number or fixed number of thiocyanate is there, thiocyanate is not going to increase. Nobody is adding thiocyanate. We are adding iron, but not thiocyanate. So what is happening is when iron is producing ferrous thiocyanide, it is not only iron, the thiocyanate is there too. So thiocyanate from here, iron is taking forcefully and then producing ferrous. So this thiocyanate will reduce. All right. So at the beginning, iron increases and then start to decrease. And thiocyanate did not increase, it just started to decrease. But ferrous thiocyanate increases. I'm not writing it here, but I'm discussing. So the test is here, test R is there, that the iron we added, right? Iron we added, and that is why it shoots up, that it increases. Suddenly we added it, and then it started to decrease. Oh, it is done already. I don't need to do it. Question number R, S. S is 1 drop of potassium thiocyanide is added. If I add 1 drop of potassium thiocyanide, so what will happen? Potassium thiocyanide also, just like iron nitrate, potassium and thiocyanide SCN will be there, dissociated. Potassium thiocyanide. So this thiocyanide is increased, right? The thiocyanide is increased in the system, just opposite to the iron. We added iron increased, Now we are adding thiocyanide. Thiocyanide increase. So thiocyanide increase here, and then it start to decrease, right? It started to decrease. Like thiocyanide is increased and it started to decrease in this way, but iron, if I take anything, now it's okay. So iron started to decrease from that side. Iron did not increase in that position, and ferrous. Why? I don't know. Okay, so ferrous thiocyanide, what is the product? It started to increase slowly in the solution. It's not that much, it's not that much, but it is started to increase slowly because both of them are decreasing. So ferrous thiocyanide should have increased in this way, not that much. Why am it start to increase, and then it goes to equilibrium. That means it goes to flat. This position become flat. That means they reach the equilibrium again. Question for T. 1 drop of sodium fluoride we added. Many of us did not do it correct. Sodium fluoride we added. Sodium fluoride is a salt, just like sodium chloride, and it will produce sodium positive ion and sodium fluorine negative ion, and it will be dissociated in the water in the aqueous medium fully. So if it happens, sodium and fluoride is dissociated in the water. So this thing, sodium cannot bind to iron because sodium is also metal ion. But let's say that we know sodium thiocyanide, it can produce, right? Sodium thiocyanide can produce. So sodium thiocyanide, if it produces sodium thiocyanide, just like potassium thiocyanide, here we added, sodium will also go and bind with this thiocyanide and produce sodium thiocyanide. Sodium thiocyanide. So now consider that sodium fluoride I added initially. There is at the very beginning, there was no influence on any of them, but thiocyanide, sodium thiocyanide started to form, right? So sodium thiocyanide started to form. That means thiocyanide is going down. It was taken from here and then it's bonded with sodium to produce sodium thiocyanide, right? Otherwise, where this thiocyanide is coming from, that is with the sodium. It is coming from here. So it is reducing in this position. If it reduces in this position, what will happen is this ferrous thiocyanide, it must be broken to fill up this gap because they were in stable position at the beginning before I add sodium fluoride, yeah. So it was stable at this nice and equilibrium position. Suddenly I add some sodium fluoride and then sodium thiocyanide started to form. And thiocyanide form, so this sodium thiocyanide, the thiocyanide part is from this thiocyanide. So there is a vacancy or vacuum is occurring here. So to fill up these vacuums, iron or FeSN was forced to go backward to fill up this vacuum. So thiocyanide can be produced. So that means it is also reducing, right? But in this case, iron is increasing because this iron is not being used anywhere, but just because the equilibrium shifts to left, this thiocyanide is being produced, iron is also increased. From what it was there, iron started to increase because it was not used that position. So for T, iron started to increase and then go to equilibrium. Thiocyanide started to decrease and go to the equilibrium. iron thiocyanate started to decrease and go to equilibrium. So this should be the curve for this. For EU, 1 drop of silver nitrate was added. Silver nitrate, if I add silver nitrate is a salt as well. All right, it can be dissociated into this form, NO3 minus, and in the aqueous medium they can be dissociated in this form. And silver nitrate, iron will produce a ferric nitrate again. This nitrate, iron will produce ferric nitrate, FeNO3, right? 3. So just like the ferric nitrate here, we added with this nitrate, iron will produce ferric nitrate because it has a good agreement, or they like each other anyway. So when iron produces the ferric nitrate, what is happening? It was before I add silver nitrate, it was imbalanced. They were stable, they are happy there. Just I added iron nitrate, the iron started to decrease because this iron was taken to produce ferric nitrate, right? And then this ferric nitrate produced, and then so the same thing is happening now. There is a void or vacancy here, so ferric thiocyanate has to be broken or dissociated to provide more iron here to go to the equilibrium again. But thiocyanate, what was in the beginning, it was not affected, so it is started to increase because of this iron thiocyanate dissociation. Of course, iron is produced as a byproduct from this. Thiocyanate is also produced. So for this case, iron is started to decrease and go to equilibrium at some point. And then thiocyanate started to increase and go equilibrium. Ferrous thiocyanate started to decrease and go to equilibrium. So this will be the thing. And for this case, we added water equal amount. If we add amount of more water, that means the volume become increased. If volume is increased, then their concentration will be reduced. So but there is, if the concentration is reduced, and the reaction will move to backward. That means here is number 1 plus 1, right? Here is 1 particle of iron, 1 particle of thiocyanate. Here is only 1. So it will go to the more number of mole side. So the reaction will go to more number of mole side, and it will be reduced and go to equilibrium. I don't know why. And then they are increasing. They slowly started to increase and go to equilibrium afterwards, like this. So this is basically should be the thing. So for the graph for KSCN, why did iron 3 ion increase? Which one you are talking? Oh, for this S, is it?
Yeah.
Okay, for S, we see that potassium thiocyanate is added, KSCN, right? KSCN is added and potassium thiocyanate will be dissociated to potassium and thiocyanate, SCN, right? Potassium thiocyanate. So the thiocyanate is being added to this reaction. If we add thiocyanate more, so the reaction is going backward. What did I do for S? No, iron is not increasing here. Iron is decreasing. This red is for iron. Iron is decreasing. And then going to this.
Oh, okay. it looks like Fe is increasing.
No. That green, blue is from here. I wanted to change the color, but I cannot change. If I take one color, everything becomes the same. Oh, so this is for iron. All right. So this is the thing. Actually, you should have been doing that way. So, any other question? Anybody has any questions so far? Chelsea, is that okay for you? All right, so I hope all the best to you guys, and then I'll see you next week, Monday. Just for your information in advance that next week tutorial, we will have the tutorial as well, and I will see you next week. But